Okay, welcome pre-methods students to this video titled Factorising non-monic quadratic trinomials. And as you start off doing this, what you're probably asking yourself is, what do I mean by non-monic? What I mean is this number here, the coefficient of the x squared term, it will not be equal to 1. So up until this point, well, in Year 9, you do factorising quadratic trinomials, but generally this number here would be a 1, which makes it fairly easy to factorise. We can use the sum and product method. But what happens when a is not equal to 1? Well, we have to make a few adjustments to the method that we use because it's not going to work if we try and do it that easier way. Now, why is this important? Well, going on to methods, pre-methods in Year 10 and then methods in Year 11 and 12, it's absolutely essential that you can do this and that you can do it really well. To be able to plot, to sketch or graph quadratic functions, you do need to be able to factorise them. It makes it so much easier to graph if you are good at your factorising. Now, there are a number of different ways to do this. This particular skill, it is a difficult skill when you first start looking at it. It is quite complex, I guess, when you first do it. But we want a method that's going to work every time. Now, if you do a couple of quick searches, say on YouTube or just on Google or something like that, you will find that there's loads of different ways to factorise. Some people prefer some methods over others. The way I'm going to show you today is, some would argue, is the long way. I think it's a good way because, you're always going to get an answer. You're not going to be sitting there stuck, and also, I guess, it eliminates some of the easy mistakes that you can make sometimes with some of the other methods. But by all means, once you get really good at it, once you get the hang of it, you should explore different ways to do it. Some people might show you some different ways to do it, and there's no incorrect, I guess there could be incorrect ways, but I wouldn't say one way is better than others. It really depends on how comfortable you are with particular methods. The way I'll show you today is very procedural. If you follow the steps, you will get an answer every time, and provided you don't make any sort of little arithmetic errors, you should be fine. Now, I've summarised the method here first, so I'll just talk about that briefly, what I mean by that, before we look at some examples. The first step always, when you are factorising these, is obviously to recognise that you don't have a 1 here, because if you do, you're not going to factorise the way that I show you now. If you've got a 1 there, you'll use that sum and product method, and what I mean by that is looking for two numbers that multiply together to give you the C value, but add together to give you the B. So that is fairly straightforward, and you can factorise really quickly that way. Once you notice you don't have a 1 there, so you might have a 2, a 4, a 10, whatever it is, can be negative as well, what we want to do is find the product AC. So I want you to take this number here, the A, and I want you to multiply it by C. So this means A times C. First we do that. Then what we do is we want to find two numbers that will multiply together to give you that number that you found there. So two numbers that will multiply to give you that AC value. But those two numbers that you select, they also need to add to give you B. So this is where it's similar to the sum and product method that we've done previously. But instead of them multiplying together to give you C, they've got to give you AC. So it's just a little extra step in there. After we do that, what we'll do is rewrite our expression. So this whole rule up here, we're going to rewrite that, but we're going to use the two numbers that we selected, and we're going to rewrite that BX term split into those two numbers with a variable X. Then we're going to split it up. We're going to factorise in two parts, and we're going to take out the common bracket that we get. That probably doesn't make too much sense until we have a look at an example. So let's do that now. First one. Okay, where is it? Here it is. Oh, no, that doesn't have anything on it, so let's go to this one. There it is. Okay, so what I've got here, First, I recognize I've got a 2. It's not a 1, so I can't factorize using the sum and product method. The other thing that you might think of doing is taking out a common factor of 2, because that would then give you an x squared term, a coefficient of 1. But as you can see, I've got odd numbers here, so a 2 does not go into 11, it does not go into 5, so that's not going to work. So what I have here is a non-monic, so I'm going to use the procedure that I explained just before. So first step is to multiply your A and your C values together. So basically I'm saying AC equals 2 times 5 equals 10. My next step is to think of two numbers that multiply together to give 10, but also add to give 11. So this one is fairly easy, isn't it? 10 and 1 multiply together to give 10, but they also add to give me 11. Okay, so I've got my two numbers now. My two numbers are 10 and 1, and they're both positive, as you can see. So my next step was to rewrite this expression here, but I want to split up this 11x using my two numbers that I selected. So this 11x, I'm going to split into 10x and 1x, which I just write as x. And then complete the rest of the expression, which is plus 5. So really the first and the last terms are the same, but this 11x is split into 10x plus x. Okay, now that I've done that, I'm actually going to do a little trick. I'm going to sort of split this in two. I usually just do that in my head. I don't need to put a line down there. And now what I'll do is I will factorize each part of this expression here. Alright, so 2x squared plus 10x. Common factors in there. Well, 2 is common, because 2 goes into 10, but x is also common as well. What am I left with? I'm left with x there, and I'm left with 5. Okay, now factorize this here, x plus 5. As you can see, there's no common factors there. But what I've noticed is I've got an x plus 5 bracket here. And one thing that you should notice when you factorize these is you always get two brackets that are identical. Because to do the final step, that's what we need. Two brackets. When we do this factorizing step here, the two brackets that we get should be identical. So what I'm actually going to do here, I'm going to take out the common factor of 1, x plus 5. So there's my two brackets that are identical, x plus 5 and x plus 5. What am I left with? What else is there? 2x and plus 1. So my final step is to take out that bracket that's the same, take it out as a factor. Because 2x times by this bracket plus 1 times by that bracket, that means that this x plus 5 is a common factor. So I can take it out as a common factor. And this is what's left. So you might remember doing that. Might have been a little while ago, but we have actually factorized by taking a bracket out before. And when you do that, this is what you're left with. And as you can see, now I have two brackets, which is what I want when I factorize these quadratic trinomials. And there's my answer there. If we expand this using FOIL, we should get that original expression that we have up the top. So let's do that now. We won't do it with all of them, but that's one great way that you can check that you've got the right answer. Let's do the first terms. X by 2x is 2x squared. Outside terms plus x. Inside terms plus 10x. And the last terms plus 5. Simplify and we get 2x squared plus 11x plus 5. And have a look, that is exactly the same as what we started with. So we've factorized, then we've expanded to check our answer. But really, if we've been asked to factorize, this is our answer here in the two brackets. Okay, so let's get a little bit more practice with that then. Here we go, another couple to look at here. Alright, first step. 3 doesn't go into 14 or 8, so let's start. A times C is 3/8 24. Now you can do most of this in your head, you don't have to jot it down like I'm doing. I'm just doing that to show you how I'm getting these answers. Okay, two numbers, they've got to multiply together to give me 24, but they need to add to give me 14. So I'm going to select 12 and 2. Alright, let's rewrite this expression using that 12x and 2x. The outside terms will remain the same. Now let's factorise this first half, these first two terms. I can see I've got 3x times by x plus 4. 3x times 4 is 12x plus, now common factor in these last two terms is 2. And this has worked out lovely because look at this, we've got two brackets that are the same, and that's what we want. We now take that bracket out as a common factor. We are left with, what's left? 3x plus 2. And there's our answer. So this factorised is equal to x plus 4, 3x plus 2. You can expand that out if you like to see if we've got it right. Okay, last one. I might use a different colour. I don't like using the same colour for the question and the answer. Here we go. We'll do the last, this second one here. Alright, again, 4 doesn't go into 23 or 15, so I can't take out a highest common factor to begin with. It's not as nice. So A times C we do first. 4 by 15, that's 60. Okay. Two numbers, they've got to multiply together to give 60, add together to give 20 and 3. So 60, it's 12 fives, but 12 and 5 is not 23. 15 and 4, obviously, because that's what we've just done. That's not going to work. It's 19. What about 20 times 3? 20 times 3 is 60, and they will add together to give 23. So that's our numbers. Let's rewrite this. Split that middle term into 2, so 20x and 3x. Now let's factorise the two parts, so 4x squared and 20x. What goes into both of those? 4x. 4 times 5 is 20. Now let's factorise this part here. We have 3 and 15, so 3 goes into both of those. X plus 5. As you can see, two brackets that are the same. That is what we need. Always need that to be able to take out that bracket as a common factor. And finally, there is our solution. There is our answer. That is the factorised version of 4x squared plus 23x plus 15. Okay. Let's do, say, well, I've got 3 more to go. This is my last slide, I promise. So just the last 3. Okay, now that we've done it a few times, we might be able to do it a little bit quicker, maybe. Okay, 6 threes, 18. Two numbers that multiply together to give me that, but add together to give me negative 11. Okay, so two numbers, 18. What have we got? Well, we've got 9 and 2. So, oh, that'll work actually. 9 and 2. The difference is 11, isn't it? So that's going to give us this middle one here. So they need to give me positive 18 because that's the number that I got before when I multiplied 6 by 3, and it's got to give me negative 11. So they both must be negative. So how about negative 9? And negative 2. Negative 9 take 2 is negative 11. Multiply them together, we get 18. Okay, hopefully I've left myself enough room here. I might just try and move that over a bit. Okay, let's rewrite this. 6x squared. It's minus, so we need minus 9x minus 2x plus 3. So split that middle term into 2 using the two numbers that I found. Okay, now we can take out a common factor here. Common factor 6 and 9, we'd have 3. That's 3x, so an x in both of them. So 3x by 2x would give me 6x squared. 3x by Negative 3 would give me minus 9. Let's factorise this part here. What have I got? Well, have a look. I've got 2 and 3, so it's not going to have any common factors. But can you see how I've got this bracket here? 2x minus 3 is what I've got here, 2x minus 3. So actually, I'm just going to take out factor of 1. Oh, negative 1, sorry. A little minus there. Now, why has this plus gone to a minus? It's because I've taken this negative 1 factor out. Okay, so as I've taken that out here, just ignore that minus for now, we're just looking at this section here. If I've taken that as a minus 1 out, it means that this here as the sign now needs to change. Okay, so now what am I left with? 2x minus 3 is a common bracket. I'm taking that out. And then we're left with 3x minus 1. Okay. Nearly ran out of space there. Okay, so this one here. 4 times 27. That's what we need to do. AC equals 4 by 27. And that's 108. Okay, so now we need two numbers. They multiply together to give 108, but they add to give me negative 24. Okay, what can we think of? Well, 12 and 9 will give me 108, but that's not going to give me negative 24, is it? So what else could I do? Maybe, what about 6 and 18? 6 by 18, yes, that works. We need them to be negative though, so let's go like this. Negative 6 take 18 is negative 24, and 6 by 18 is 108. This works, okay. So this one is a little harder, I'll admit. So split that bx term into the 2 using those two numbers. And now we can factorise. So 4x squared takes 6x. Let's take out a common factor of 2x. And we'd be left with 2x minus 3. Okay, common factor here, 18 and 27. Well, that would be 9. 2x minus 3. It works. I love how every time you get this same bracket, you know you can breathe easy because we know that's what we want. That is exactly what we're searching for. That same bracket, now we can take out that and we're left with 2x minus 9. And we're done. Okay, final example. Let's do this one together. A times C, now it's negative. Okay, so AC would be negative 10. So two numbers that multiply together to give you negative 10, but they need to add to give you negative 3. So I'm thinking already 5 and 2 because the difference between them is 3. So that gives me an indication. I need to get it to a negative, so I'm going to make this one here negative. Negative 5 plus 2 is negative 3. Multiply them together, you get that negative 10. So rewrite using those terms. There we go. Now let's factorise. So this one here, 2 and 5, both prime, so we're not going to get a common factor there, but I do have a common factor of x. And have a look, 2x take 5, I've already got that there, so take out a common factor of 1. Oop, nearly don't fit. Okay, well maybe I could move it over a little bit. Alright. So we've got the same bracket, final step, 2x minus 5, take it out, what are we left with? X plus 1 in your next bracket. And we are finished. So as you can see, it is a little bit more complex than that sum and product method where our number at the front here was just a 1. But of course, as you add this extra complexity of this number here, obviously the procedure is going to get a little bit more complex as well. So main things to remember are do your A times C, so you get that number, then you do your sum and product using that number. Product has to be negative 10, sum needs to be that middle term still. split the bx term into 2, factorise in 2 parts, so factorise the first 2 terms and factorise the second 2 terms, then you should get the same bracket here, exactly the same. If you don't, there's something wrong. Okay, you get the same bracket, you take it out as a common factor, and the remaining terms there are what make up the final bracket, the second bracket I should say. Alright, thank you very much for going through this video with me, and good luck with getting lots of practice with this. Like I said, it's really, really important. Thank you.